Okay, so this is the probability chapter. Remember, if you have a copy of this, I would suggest that you do the problems on your own first, timed 1 minute per question, and then attempt corrections on your own afterwards for the best results, and then use this video for explanations on anything that you're stuck on. Also, keep in mind that I will be updating the video description for each video over time with helpful links to other videos that you might want to reference if you need a review of the specific content in that video chapter. Okay, so let's get started. This one's going to be a little tricky to film because it's so big. Okay, so pause to read if you haven't already. So you have to think for probability, what the desirable outcome is over the total number of outcomes for each event. And then if it says or, that means you're adding those probabilities. So first we're going to find the probability that it's a white flower that blooms in spring. So let's go to white flower blooming in spring. That's going to be 600 out of the total number of flowers. And that's going to be 3,700. So this is the probability that we have a white flower blooming in spring. And then we're going to add the probability that we have a white flower blooming in summer. So we're looking at white flower blooming in summer. So we're talking about 560. And then the total number of flowers on bottom would be the same thing, 3,700. So now we're going to add these up. So we're going to get 1160 or 1,160 if we want to be all, proper, over 3,700. And then you'll see these are in decimal format. That's just meaning that you have to do the top, the numerator, divided by the bottom number. So in your calculator, you would put 1,160 divided by 3,700. And when you do that, the answer would be B. Okay, so now for number 2, pause to read if you haven't already. Now, this question is a great example of why it's important to pay attention to the if given statements, like the ones where they tell you if yada yada happens or given yada yada. And in this case, if a female cat, sorry, someone just texted me, you're picking from a female cat population, you're picking just out of the female cats. So that's the population you're picking from. So we have to think that in terms of the total number of female cats. So the total number of female cats would be 6 plus 9 right here. So that would be 15. And then we're going to say, okay, we want the breed, the desirable outcome to be that the breed is a ragdoll. So we're looking at ragdoll for the females. So we're talking about 9 out of 15. And then when you plug that in and round to the nearest hundredth, you would get A, 0.60. Okay, pause to read number 3 if you haven't already. So the circled portions are the desirable outcome, or is the desirable outcome. So we're talking about Team C, they could be in 9th, 10th, 11th, or 12th grade because they have to be in at least 9th grade. So the desirable outcome would be on top of our fraction bar, so 25 plus 25. And on the bottom, we need to look at the given or if statement. In this case, it's a given statement, and they say given that the participant is in at least 9th grade. So that means we're picking from 9th graders, 10th graders, 11th graders, and 12th graders, meaning all those 9th graders, all those 10th graders, all those 11th, all those 12th graders. So if you look at the columns, they tell you the total number for 9th to 10th grade, so that would be 70. And then we also have the total number for 11th to 12th grade, 70 as well. So you would just do, you could do this in your calculator too. 25 plus 25 is 50, 70 plus 70 is 140. And then you could cancel out the zeros and do 5 divided by 14 in your calculator. You could technically put 5/14 as your answer as well. But I feel like most people would just end up doing 50 divided by 140 in their calculator. And then if you were to do that, it would be, let's see, 0.35714 yada yada yada. And remember, you're only allowed 4 characters for positive free response answers on the digital SAT. So it would be the decimal is 1 character, so 2, 3, 4, 5. So this would be the way that you write it. Okay, pause read number 4 if you haven't already. So we're being asked for this to be our desirable outcome, that we pick a senior. So on top, there would be 60 seniors. And then on the bottom, it would be that we're picking from the total population of students, meaning all sophomores, juniors, and seniors, which would be 160. Now you could cancel out those zeros, and then you could simplify this fraction right over here. We could say that 2 goes into both of those. So that would be equal to 3/8. You're also free to turn this into a decimal if you prefer that. Okay, pause read number 5 if you haven't already. So this is the information we've been given, where I'm just saying like the probability of green is equal to 3 times the probability of orange. Probability of green is also equal to half the probability of picking a purple ball. And then the question's asking us to find the probability of picking an orange ball. If I add up the probability for each of these scenarios, like probability of picking a green, probability of picking an orange, probability of picking a purple, it adds up to 100%, or in decimal format, 1. So what I'm going to do now to solve for the probability of orange is I'm going to rewrite the probability of green and the probability of purple in terms of probability of orange. So I already have that probability of green is equal to 3 times the probability of the orange. So I'm going to plug that in right over here. And then I already have, obviously, probability of orange is right there. Now I need to rewrite probability of purple in terms of probability of orange. Well, I can say if I multiply each side by 2 here, I would get that 2 times the probability of G equals the probability of purple. So I can now replace the probability of G with 3 probability of orange to say, oh, 2 times 3 times the probability of orange is 6 probability of orange that we're talking about here. So I could replace probability of purple with 6 times the probability of orange, and then say that all equals 1. So basically, this is my unknown variable that I'm solving for, right? So I'm going to combine my like terms there. That's going to combine to give me 10 probability of orange, 10 times the probability of orange, is equal to 1. Now divide each side by 10, and I get that the probability of orange is equal to 1/10. Okay, pause read number 6 if you haven't already. So we want to find the probability that we will be in the scribbled region for this figure. So let's call the area of the small figure, of the small circle, x, and the area of the large circle 4x. Because if we want to know this probability right here, we have to think, okay, I'm thinking in terms of the area that's scribbled, that's my desirable outcome, out of the total area of the figure to find my probability that I'll be in the scribbled portion. So I have to think, okay, how could I find the area of the scribbled portion? Well, if you look right here, it's half of the big circle right here would be all of this right here. So like 2x, because I would divide the area of the large by 2 to get the area of half of it. But that includes the blank space right here that doesn't include the scribbles. I don't want that. So I have to think, oh, I have 2x, and I'm going to subtract out whatever, let me use a different color, whatever this area right here is in yellow. So I have to think, oh, that's the small circle. It's half of the small circle's area. So it would be half of x that I'm subtracting out. And that's just going to give me 1.5x. Or 1/2x, however you want to write it, 3/2 x, whatever floats your boat. So that's the desirable outcome. That's where I want to land, in that scribbled area. So I have to do, for probability, my desirable outcome over the total number of outcomes, which would be the total area of this whole large circle, the area of the large circle, which I know is 4x. Now, this would be equivalent to 3 halves. 1.5 is the same thing as 3 halves. So I could say I have 3 halves divided by 4. And then I'm going to skip down here. Keep, change, flip says I'm going to keep 3 halves the same, change division to multiplication, and then flip 4 over 1 to become 1 over 4. So then that's going to turn into 3/8 as my answer. Okay, pause to read number 7 if you haven't already. So let's call the total number of animals at the shelter X. So we're going to say what's going to equal the total number of animals X? Well, it's going to be the 27 cats, the 17 dogs, and then the 1/3 of the total number of animals being the hedgehogs. So this 1/3 times X would give me how many hedgehogs there are. And if I add all that up, I get all the animals at the shelter. So all I need to do now is combine like terms and solve for my X. And then once I have X, I can obviously plug that in over here to find 1/3 of X to find the number of hedgehogs. So essentially we're finding X and then plugging it in here to get the answer to the question. So let's do that. So we have 44 plus 1/3 X is equal to X. Now I'm going to subtract 1/3 X from each side, and that's going to be 44 is equal to, and then that's going to leave 2/3 X over here. So then to get X by itself, I'm going to multiply by the reciprocal on each side, multiply by 3/2 on each side. So now I have 44 over 1 times 3/2 is equal to X. 2 goes into itself 1 time, and 2 goes into 44 22 times. So now I have X is equal to, well, 22 times 3 is going to be 66. And now, remember, this is what we wanted to find, the number of hedgehogs, which is represented by this. So I need to find out what 1/3 of X is, or what 1/3 of 66 is. Well, 1/3 of 66 is just going to be 22. So D would be the correct answer. Okay, pause to read number 8 if you haven't already. So we want the probability that the crown is not blue. So we have to think, okay, desirable outcome goes on top. So that would be that it's either red or green, because those are the not blue colors. So 2 plus 1 out of the total number of outcomes, which would be the total number of crowns, which would be 10. So then it's going to be 3/10, or B as your answer. Okay, pause to read number 9 if you haven't already. Okay, so you have to think of the chances of each of these things happening and then multiply by them to find out the probability of this and this and this, basically. Like whenever you see and or both with probability, typically you have to multiply each individual event probability, and that'll give you the probability of blank and blank happening. So if they're picking 2 out of 3 candies, they have the ability, or the probability, I should say, would be that 2 out of the 3 that they're going to pick could be like the chocolate and the sour candy. So after that, they're going to have only 2 options left to pick from, because they're going to have picked 1 out of those 3 candies already. So there's 2 total options left. And then let's say that they already, in this situation, we're saying that they already picked either the chocolate or the sour candy. So now there's only 1 desirable option left. So the probability would be 1/2 for picking the second, picking both of those candies for this first portion of the problem. Now we have to multiply by the second part's probabilities, which says that we're doing 2 out of the 3 snack items. So it's like the similar situation right there. But we are only going to be interested in picking a corn dog. Or sorry, interested in picking a corn dog and a popcorn. So again, there's 2 chances, like you're picking either the popcorn or the corn dog out of 3 snack chances, I guess. And then once you've already picked that, one of those desirable options and total options are gone. So now you're just left with 1/2 that you're multiplying by. So the probability of selecting chocolate, sour candy, popcorn, and a corn dog would be multiplying all of these together, or be found by multiplying all these together. The 2's cancel out because cross-canceling. So then it's just 1 times 1 is 1. And then 3 times 3 is 9. So that would be 1/9. That was a tongue twister. Hopefully I didn't confuse too many people.